So, good morning and welcome to today's webinar titled A New Way to Cut to Length, Dye-Free Laser Blanking, presented by ANDRITZ Schuler and hosted by Metal Forming Magazine and the Precision Metal Forming Association. My name is Brad Kuvan, Editorial Director of Metal Forming, and I'm pleased to be your moderator for today's session. Before we get started, just a few notes about today's Zoom meeting session. It is being recorded, as I said, for archiving, and the recorded event will be posted to our website within the next few days, so we'll let everyone know via email when that recorded webinar is available for viewing online. Also, all participants in the meeting are in listen-only mode, which means that the speaker and other attendees will not be able to hear any audio from your site during the program. However, you do have the ability to communicate with us throughout the program by submitting your questions and comments using the Q&A window located at the bottom of the Zoom screen. We'll address any questions at the end of the presentation. So we'll go ahead and get started with today's webinar. We're going to learn about laser blanking technology, which promises to optimize flexibility in order to efficiently produce unique parts, including those from high tensile strength steel as well as from aluminum alloys. The presentation will unveil the system's substantial material utilization rate by using intelligent crosscuts while producing blanks at up to 45 parts per minute. Then we'll hear from a company that's actually using the lines, BWD Technologies, which operates high-speed coil-fed blanking lines at its facility in Dearborn. Our speakers this morning are Justine Fontaine, Area Sales Manager of the Americas for ANDRITZ Schuler, and Chris Kristock, Technology Manager at BWD Technologies. So to get things started, please welcome Justine.
Thank you very much. Hello also from my side. My name is Justine Fontaine. I've been working with Schuler as an area sales manager for more than 6 years now, and I'm very happy and honored to present our latest laser blanking technology to you today, a new way to cut to length. Okay, here we go. We start with the first introduction of ANDRITZ as a global player for industrial solutions and equipment. So ANDRITZ integrated Schuler 2013 already. However, the full migration was only done earlier this year. So that now Schuler is part of the ANDRITZ Metals division. And next to that, ANDRITZ is also a global player for pulp and paper, hydropower, and environmental and energy solutions. We have more than 30,000 employees worldwide, organized in more than 280 locations. So we are situated now in the ANDRITZ Metals division, and with Schuler, we are completing the US team of ANDRITZ Metals, which provides reliable services for cold processing, finishing lines, furnaces, tooling, welding, but also services like spare parts, customer service, and other services like reconditioning or training for several types of equipments. By integrating Schuler, ANDRITZ has now the opportunity to provide equipment and solutions for the whole product cycle, starting from the steel manufacturing up to the finished parts. And as ANDRITZ Schuler, we are more located in this end process. And today we are talking about the blanking technology. ANDRITZ Schuler has more than 50 years of experience with laser technology. And with that heritage, we have the possibility to answer the demands of the market. In the last years, we saw an increasing rise of variants, smaller batches, smaller product cycles of vehicles, and also a trend towards lightweight construction, which brings various materials into the game, and also a lot of product-specific parts. And to answer that request, we developed a high-performance laser blanking line a couple of years ago that is not only producing high performance, so comparable to a conventional blanking line, but also completely dye-free. So everything related to dyes can be eliminated, and also a product-specific tooling can be eliminated so that prod chains can be much faster, and therefore you achieve much more productivity of your actual line. And now we jump right into the topic. So Schuler, or ANDRITZ Schuler, is coming from a blanking heritage. So we have years of experience with outer body panels mainly. And that's also where we started with our laser blanking developments. So the first laser blanking lines were introduced as an alternative to blanking lines with press. And they are really dedicated to exposed materials and also very sensitive materials like aluminum, for example. And today, I would like to talk about the LBL 1.18 DFT. So this technology is dedicated to cut-to-length lines, or as an alternative to cut-to-length, but also for small batches of structural parts, including a high accuracy package to cover also the high accuracies, for example, for hot forming. This line is also capable of processing thicker materials up to 6 millimeters, and is suitable for exposed, but also or mainly for unexposed parts, but also for exposed parts. And before we go deeper into that topic, I would like also to mention our LBL 1.18 stop-to-cut solution. So whenever we are facing limits with our DynamicFlow technology, for example, in terms of very high accuracies, then this would be a nice option. It's also designed for smaller batches and can handle even material thicknesses up to 12 millimeters. So the key is that we are really designing our lines dedicated to the parts you would like to process, and that we came up with the best solution for your business. Okay, but let's jump into the new way to cut to length. So the 1.18 LBL DFT is not only a reduced version of the 2 laser head system, even though it comes with 1 laser. So our concept is to replace the laser, to replace the shear with the laser. And that way you are able to not only do cross cuts like straight cuts or trapezoids, but also intelligent cross cuts like an S shape, or even unique shapes, as you can see here on the picture. You also see some cutouts, so this is also a possibility that you can add in your process, and that is a big plus compared to a conventional shear line. The geometries can be flexibly adapted so that you can increase your material utilization. I have a couple of really good examples for that later for you. For now, I would like also to show you that this line is a very compact solution in terms of space. So it's about 50% smaller than conventional cut-to-length lines or conventional press blanking lines, and it runs completely continuously. So therefore, we do not need any loop pit or other big civil work for the installation. Talking about the overall layout. So as a normal cut-to-length line, it also comes with an uncoiler, a cutting area, and a stacking area. But what is very specific here is that we are taking the coil and then we go directly into the leveler. So there is no in-feed unit in between. And then we use the leveler to go into the laser cell. So that way we can reduce not only the loop equipment, but also the feeder technology. Our levelers are cassette designs. So that means that you can use different types of cassettes for specific materials. So for example, for aluminum or steel, but also different thicknesses. So if you have thinner material, you can use a different cassette than with thicker materials. And yeah, with this cassette system, you have flexibility, and we can also add an automated cassette exchanger so that you don't need to do all of this manually. So once the material goes through the leveler, it's been pushed into the laser cell. So here we are cutting with one laser head and in dynamic flow. So that means we won't stop the line. The material flows constantly with the same speed through the line. All the good parts and the scrap remains on the belts and are pushed out of the line on this exit conveyor you see on the very end. And then we have a feeder that picks the good parts, stack them on a stacking cart, while the scrap remains on the exit belt and moves into the bin at the very end. So here we have different options. In this picture, you can see a one feeder system, but we are also able to add a second feeder on the same gantry to double the capacity. And we also have two stacking areas. So one is on the operator side and one is on the drive side, so that you can run continuous production and exchange your stacking carts when they're full. We also have this option with this little yellow pyramids on it. So this is a system to actually scan the edges of the blank and to enable the system to have a perfect piling on the stacks. Our feeder comes with universal tooling. So that means you need no product-specific tooling. And it can take more than one part if the parts are small enough. And we are also able to reorientate the part so that you can do better nestings during your cutting process, but also be able to have closer nestings on your stacking cart. And this is how it looks in production. So you can see here the belts moving the strip material forward in a continuous way. You see the laser gantry with the laser head moving back and forth to cut the geometries. And underneath, you can see that we are using shafts to make a little gap for the laser cutting, but also we are able to open those shafts to eliminate smaller scrap parts directly in the laser cell. So this ensures a reliable process without having the risk of little small parts jumping around or getting stuck underneath or something like this. What I also wanted to show is that we have a very closed design. So that means we do not have laser dust all over the place. We have dust exhaustion, a fume system where all the dust is collected and filtered so that there's no harm for people and equipment. Our laser blanking line runs in dynamic flow. So that is what we tag the continuous cutting. Our line can be equipped with a 4-height leveler or a high precision leveler with 6 levels with support rolls. We can integrate up to 10 kilowatt lasers. So depending on the thickness of your material, we define which one makes the most sense, starting at 4. And as I mentioned before, we have either the feeder as a single solution, or we add another one to make it a double feeder. We can cover coils with a maximum width of 74 inches, and the maximum thickness would be 0.23 inches. Steel, aluminum, and stainless steel can also be processed, and which is really interesting for those that are processing high strength material. Our laser blanking line has no problem with higher yield strength that are more than 1,000 MPAs. As for the laser process, it does not really make a difference if it's higher yield strength or not, while for the mechanical systems, it does. So we have some customer that really chooses the laser blanking just because of those increased high strengths. With our systems, we are able to cut up to 45 parts per minute. So we are talking about cross cuts here, and also parts that can be stacked with 2 parts at a time with a double feeder. But most of the time, the rectangular blanks are not really the blanks you want to have, but they're easy to get. And what we are promoting here with our intelligent cross cutting is that you're getting closer to the actual shape you would like to have, save material, and use the same output. And I have some examples here to get you a bit into the topic. So here you can see an example for straight cuts or trapezoids that would normally be run on a cut to length line directly from the coil. So the first one is the hood. So you can imagine cutting out a hood out of a rectangular blank that you would have the yellow areas as scrap. And what we propose now with our laser blanking solution is that you can modify the straight cut into an omega shaped cut so that you can do an edge to edge nesting of the actual blank you want, this hood, and save 13% of material. And those of you that are familiar with oscillating shears already know that you can get much more of material savings already from the oscillating movement. But here, looking at the second example with the fender, you see that you can save even more if we are talking about an S shape, and also here cut edge to edge so that you can use the yellow areas that would be scrap if you would use trapezoids instead of this intelligent blank. Another example would be intelligent master blanks. So we regularly see that rectangular blanks are used in flatbed laser processes afterwards to cut the actual part. And what we have here as an example is that you are not using the full rectangular blank, but a multiple nesting of the parts you want to get and make an intelligent crosscut here. So that means you would not have a rectangular blank, but this gray area as a new blank to introduce to your flatbed laser. And then you could, same with the rectangular blank, cut out 4 of those parts, but you can also use the corners for the previous intelligent blank or the next. So you could save 12% of material saving. The last example is to cut the parts directly from the coil. So this is an example we had with a customer cutting those shaped blanks out of a rectangular blank. And you see on the yellow areas, this is all scrap. So 33% of the actual blank is scrap. And by doing a continuous nesting from a coil, you can already save 17% scrap. So in this scenario, you would just have 16% scrap. And what comes on top with that solution is that we can use a second laser head on our gantry to make the 1.18 to a 2 laser head system. and to double the output. So that means you would have half the scrap with double the output by using the option of a second head on the same gantry. So this is not the standard, and this option is very beneficial if you have symmetrical parts or symmetrical nestings, like you can see here. So the lasers would do the exact same movement at a time. Talking about output, so I already mentioned that we can achieve 45 parts per minute. So this is actually all based on one laser head. And this is also our standard. So the 45 parts per minute are valid for smaller feed lengths. That's where the feeder can pick 2 at a time. Otherwise, the feeder kind of limits the output at 22, as you can see on the very first examples. When the feed length or the thicknesses get higher, then you can see a little less output. This solution enables us not only to do straight cuts or cross cuts, but also cuts in length. So it might be interesting to cut maybe smaller rectangular blanks from a bigger coil to avoid, for example, one slitting step. So that might be interesting for smaller batches maybe, or yeah, if you want to use only one kind of coil variety. The next example shows how you can include cutouts, but here you can see that the output immediately drops to 15 because of that cutout. So it is possible to integrate them, but we always recommend to have the cross cuts as main jobs for your line and only add parts with unique parts or cutouts in the product mix on a smaller scale. Yeah, so to get some more examples, we included also some circular blanks nested either completely on a blank on the coil or 2 next to each other. The next point would be the footprint. I already mentioned that we are at approximately 50% of the actual size of a conventional cut-to-length line. And here you can also see that we save a lot of work in terms of the loop pit. So in the picture below, you see a conventional cut-to-length line where we have the big loop pit to disconnect the continuous coil feeding with a start-stop motion of the shear. So that will be the same also for a conventional press blanking. And then at the end, you see some little holes for the lifting devices of the stacker, which can be eliminated with our feeder solution. On top, you see our laser blanking line 1.18 DFT, where there's only one little area in the foundation to actually lift the coil. But other than that, everything is mounted completely on floor. The full size is 26 meters in that standard version, and a full cut-to-length line would be 48 meters. So it's not really 50%, but we are very close to that. And this is how it looks in real. So on the left side, you can see your the on-floor setup of the installation. We just have those foundation plates. In this special case, we have also connections to a scrap conveyor system. So this is the little fences in the back. Other than that, we also need very little trenches, as everything is mounted on platforms, as you can see in the second picture. So basically, we just have here the in-feed point from the customer, and then one trench in the floor going into our platforms. And from there, everything is distributed into the line. So all the cablings, all the pipings is also on floor in that pipelines. in these platforms. You can see also that we use the cabinets as fans. So we really thought about this being the most compact possible design to fit also in the smallest corner of your facility. All of our lines are pre-assembled. So we do a pre-assembly in our facility first to make sure that everything is up and running. And then we have a pre-acceptance test by our customer before shipping. And then we do the installation and the commissioning on site. To end the technology portion, I would like to highlight two options. So the first one would be the Class A package, which comes with additional in-feed unit with cropping shear and also brush cleaning devices for the belts and the blanks. And the second option I would like to highlight is the part marking. So this is done with a separate laser that is installed also in our laser cell, but is not, however, linked to the cutting process. So this is an extra laser that is doing the marking so that you have a traceability of your parts. And on the long term, if you're interested, you can also add this to a track and trace system. So to summarize, the LVL 1.18 DFT is a compact entry into our laser blanking technology. So it's a proven system, and we also have local service for that. In that kind of blanking line, we use the laser instead of shears or oscillating shears. And this enables the customer to not only do cross cuts, but also any kind of shape, also with cutouts. That way you can increase your material utilization. We saw 3 examples with very high potentials with more than 10%. So it's definitely worth looking at it. And I'm pointing that so much because we have several customers that were already able to calculate their return on invest based on material savings. And then we have this compact design, which is, I think, a very big benefit in terms of floor space, and also that you do not need any foundation work like a glue pit or something is a big plus, as you can put the line pretty much anywhere. So we have customers that are using former coil storage places, for example, or second floors. And then you can achieve also here 45 parts per minute. Doing cross cuts, of course, unique parts drop a little. But if you're interested in the output you would have on your specific parts, we are always happy to help with output calculations. Support service. So we have several lines installed in North America, and therefore we established also a very powerful service infrastructure with several facilities in North America, so Canada, US, and also in Mexico. And this team can support with launch assistance, troubleshooting right away, spare parts, and they are backed up by our product specialists from Germany that have always remote access also to your lines. On top of that, we are dedicating always a local project manager during the installation phase. So that means that you have always one point of contact in your time zone that is taking care of all your issues or requests. And we also know from a couple of our customers that are cooperating and backup solutions with their laser blanking line solutions. So that means if you choose to go with laser blanking, you're definitely not alone. And we are there to make a smooth transition towards laser blanking. References. So we have 24 laser blanking lines sold worldwide so far. It all started 2012 with our first prototype. And since 2014, we are providing equipment for a big OEM that is using them for serial production of their cars as well. Since then, we were also able to establish that technology in the American market. And BWD was the first company who really adopted that new technology. And since then, we were able to sell 7 more. At this point, I'm very happy to introduce our guest, Christopher Christock, Technology Director at BWD Technologies. Chris has 34 years of steelmaking, finishing, and coating experience, and 11 years of metal processing experience, including laser applications. And BWD Technologies runs the first laser blanking line in the US and is currently setting up the second one. So we are very happy to have you here, Chris. Welcome.
Thank you.
And looking forward to your insights of operating laser blanking lines.
Well, thank you, Justine, for that introduction. And I want to say that BWD Technologies is honored to participate in this webinar by providing a summary of actual experience with the laser blanking equipment provided by ANDRITZ Schuler and our laser blanking process that it enables. After several years of study and internal consideration of high volume coil-fed laser metal blanking requirements, the purchase and installation in 2023 startup of the DFT equipment from ANDRITZ Schuler significantly changed the course of our company for the better. The initial BWD facility, Blanking Without Dies, is located in Dearborn, Michigan, across from the iconic Ford Rouge plant. We officially began the journey into laser metal blanking with ANDRITZ Schuler in 2018 after witnessing the line in operation at a facility in Germany. We have been producing laser cut blanks for the automotive, truck, and appliance industries since 2023 September. It's difficult to pinpoint the single most important factor establishing the need for laser blanking, but I believe that the significant market change brought about by the drive to implement electric vehicles was a major factor, as the data shows a significant increase in rate of startup automotive companies and commensurate increase in new model launch plans correlating to EV manufacturing. These new startup manufacturing facilities were geographically located in new regions and each held a market share that created intense focus on cost savings and flexibility of the manufacturing process. This exposed capital inefficiencies associated with mechanical blanking, namely the expense of blanking dies and complex facility requirements such as overhead cranes, significant foundation work, and storage space. There was also an ongoing requirement for press and die maintenance to consider in a supply chain, which increased manufacturing cost pressure for these lower volume niche vehicles as EVs were being marketed. ANDRITZ Schuler's DFT equipment and BWD technology mitigated these cost concerns with a robust laser blanking line that is capable of high volume laser cut blank production. Other drivers of the need for laser blanking includes the affordable co-location of blanking facilities near automotive manufacturing facilities, the freedom from press tonnage requirements to blank newer high-strength materials, the flexibility and capability for rapid production of prototype trial blanks, and the ability to incrementally modify blank shape design to achieve best-in-class stamping quality and to produce near net shape blanks where costly trimming after forming could then be minimized or eliminated altogether. Laser blanking has the benefits for both the producer or the blanking operation and the consumer or the stamping operation. While the footprint of the machine that we purchase resembles that of a mechanical blanking line, the elimination of space requirements for dies, die maintenance shops, and storage space for press parts creates facility space for additional revenue-generating activities. The DFT laser blanking equipment requires much less maintenance than either mechanical blanking or older technologies for laser metal cutting and blanking. It has, by virtue of its continuous coil feeding and integrated controls for laser motion, a much higher productivity rate than individual sheet-fed laser cutting machines. The job-to-job transition is greatly simplified by loading a new coil to the line and then virtually loading another CAD file for the subject blank versus the time required for die setting and die exchange. Stamping operations benefit through the unique nesting opportunities leading to higher material utilization and associated cost savings. The flexibility of laser blanking features is appreciated by tool and die personnel as it gives them additional options for blank shape to improve stamped panel quality. Many constraints for blank features in mechanical blanking are eliminated in the laser blanking process. BWD continues to receive positive feedback from our customers about the quality of our products we have supplied using the laser-based DFT process. Customers appreciate our responsiveness to inquiries and are able to utilize the flexibility of laser blanking to achieve cost and quality benefits, as well as speed to market ability. Our blank and blank stack quality is best in class. The use of full width rubber coated belts for conveyance in the laser house leading up to the stacker has all but eliminated surface defects such as dents, pits, and scratches associated with mechanical blanking, and the clean cuts afforded by the laser with optimized laser cutting parameters, along with the continuous surface brushing of both the belts and the blanks in the DFT process, results in the elimination of draw die dirt contamination resulting from mechanical blank burrs and slivers. The quality, cost reduction, opportunities, and flexibility afforded by the use of ANDRITZ Schuler's DFT blanking process is part of BWD Technology's short and long-term business plan. At the present time, we are installing a second line in our Dearborn facility, which will begin producing blanks in March of 2026. That's the picture on the left. Concurrently, the process for an additional third BWD line with our JV partner in Querétaro, Mexico, has begun, and we will begin supplying customers in May of next year. Both of these lines add to the laser blanking production capacity for BWD using ANDRITZ Schuler's equipment. Our long-term plan as the laser blanking process moves along the adoption curve includes a vision for a network of laser blanking machines that are co-located in existing and developing automotive manufacturing regions. This is possible because of the lack of heavy machinery involved in the DFT process, which enables the use of existing sites for implementation or requires lower capital investment for new facilities to house the equipment and execute the process. We are also involved in working with our customers to leverage the relatively unconstrained blank design features of the BWD DFT process for improvements in material utilization that you heard Justine speak about. Our work and laser blanks also generate improvements in the quality of existing stamped panels as documented by our customer feedback. In summary, we equate successful implementation of laser blanking processes executed using the ANDRITZ Schuler machine as the observable transition of customer supplied blank designs to those that not only improve stamped panel quality, but also support high productivity in the laser blanking process. Thanks, Justine.
Oh, thank you very much for that insight. So this was our part of the webinar. I hope you have enjoyed it. And now Chris and I are ready to receive your comments and questions.
Terrific. Thanks to both of you. And yep, I see the contact information. So some of the attendees were asking for your contact info. So you may be getting some emails from our attendees. So we have some time left over for questions. Please go ahead and use that Q&A panel at the bottom of your Zoom screen if you have questions for Justine or for Chris. The first question, Justine, in terms of the leveling capabilities of the line, can you speak to that in terms of maximum strength of the material, width and length?
Yes, sure. So for the leveler, it's always key to have like the cross section, right? So you have a mix of the maximum width, the thickness, and the actual yield strength. And depending on your material you would like to process, we can adapt our levelers. So for the laser blanking line we are promoting here, we can achieve or process materials up to 6 millimeters. When you are interested in more, it's also possible, but then we would just need to talk and customize. And in terms of the leveler, we also have a very interesting feature. It's called a stop. No, it's called check to flatten, where we are tracking the results of the leveler constantly and are able to feed back that to our support roles that can be adjusted accordingly, so that you have always a perfectly flat material for your laser process. And of course, we consider that you don't want to have material level to death, let's say, and that you still need some flexibility in the material for the further forming process. So yeah, that's all about our levelers.
Okay, so in terms of maximum strength of the material, high strength steels, for example, you can handle.
Yes, so we can go. So I think the highest we sold so far is at 1,500 MPa.
Okay.
But now being part of the ANDRITZ group, we can also team up with our sister companies, Sundvik, for example. They are building equipment for the steel manufacturers, and they can even handle higher yield strength than that.
Very good. Okay. Can you speak to what you've seen your customers, and maybe Chris can add to this, in terms of OEE? What type of equipment effectiveness do you see? And the second part of this person's question is the equipment available in India?
Okay, I can speak to the first part of that.
Sure.
Justine handle the India question. Yeah, our quality performance from the line is very close to 100%. Once the machine is operating on a continuous motion basis and the coil quality remains the same, there is almost no rejects occurring during the blanking process. It's very, very effective in that regard. Some of the things that impact the total OEE, including the size of the coils that you're receiving and the length of the coil run, can impact OEE in a positive way. So machine utilization is really directed by the operators. The assist gas interaction with small pieces of scrap, as Justine mentioned, is a consideration that sometimes slows down the actual run rate compared to the predicted run rate. So OEE is downgraded in those instances. But the flexibility of the equipment, in our case, we have a vintage that was produced in 2017. We have lots of opportunities to manipulate the way we run the machine. So we've had some jobs that started at around 7.5 blanks per minute production rate that are now running at 18 blanks per minute. And that's really a testimonial to the experience of operators operating a very flexible machine from Schuler.
Yeah, so
Excellent.
let me answer the Indian part. So actually the equipment is available all over the world. We have references from Indonesia, in Saudi Arabia, and the US, Europe, wherever. So even South Africa have one. So yeah, of course, the material or the equipment would also be available in India.
Very good. Can you speak to payback factors related to downstream stamping?
Well, our customers are telling us, and we have observed this with many years of experience in the trade of being an automotive tier 1 supplier of rolled metal. Their experience is incredibly positive. We have supplied over 600,000 exposed body panels, mostly hood outers, door outers, and body sides, without a single reject for dirt in a draw die. In one of our references, the customer indicates the savings of close to $250,000 in the first year using BWD supplied laser cut blanks, mainly because of the improved cut edge quality that's afforded by a laser which is properly operated. So setting the parameters correctly, running at the right speed, gives the customer a pristine edge that does not generate slivers or pieces of burr in the draw die, and that runs so much smoother for them. They're very happy. I've had one customer tell me we will never source another exposed body panel outside of laser metal blanking from BWD. They're really happy.
That's a great testimonial.
Yeah.
So, and we do another question related to the comparison of the laser cut edges to die shear. I think you pretty much covered that. Is there anything more you'd want to say about the comparing the two edges?
Well, if you look closely at micrographs of the two edges, there's really no comparison. Our edges are straight. We have no shear to break ratio. We have no burr. We have no rollover. You can witness the vaporized layer and the melted layer in the laser cut blank, but we're blowing assist gas through a 190 micron channel at up to 200 psi. So we're absolutely not adhering any of that cut metal, that melted metal, to the bottom surface. It's blowing straight through into the dust collection system. So our edges are, well, they're almost perfect, let me just say. And that is really reflected in both draw die performance for exposed panels, and the literature will tell you that laser blanking provides much higher edge ductility for edge stretch applications, bested only by water jet cutting, which at this present time is not affordable in a manufacturing scenario.
Yeah, maybe one thing to add, because I hear this question a lot about edge hardening. So some customers are concerned that the laser would cause edge hardening, but actually with the new fiber laser technology and the powerful lasers that pretty much evaporates the material immediately, there is hardly any energy going into the edges. So there is no risk of edge hardening with our technology.
And that's documented in the literature if you care to look it up.
Very good. One of the attendees says that they're working primarily with material that is only 6 inches wide. Is there a solution for them with this technology, or is that too narrow of a strip?
I would refer that to Justine.
How much is 6 inches?
Well, it's 16 inches is 400 millimeters, which is sort of a minimum size for our machine.
Yeah, so 400 millimeters?
No, 6 inches is
13 inches or something.
150 millimeters.
Oh, so that would be a bit small, to be honest. We can look at this more closely, but normally we start at 200 as a minimum coil width in millimeters. Okay. So sorry for the inches conversion. Yeah, so we start at 200 and go up to 1,880. Smaller, okay, but we can discuss actually. So that would be a customized adaptation we could think about.
Okay, good. The question is, we deal with a mix of raw and pre-painted coil. Any issues with running pre-paint through a laser system like this?
So we would need to check the coating. There are some coatings that are actually approved for the laser cutting process. If there is no concerns with that, we can also do that with the pre-coated material. For now, we used, or what we cut already is material with a foil or with paper layers, and we also have solutions to either go through with the material or in the paper case to rewind that paper.
Good, okay. I'm going to ask this question, but I'm not exactly sure what they mean. Maybe you understand it. We mentioned the maximum production of 45 pieces per minute in the intro. Can it be higher than that with, it says 1 or 2 Cartesian and single or double blank stacking. But if you're running coil, I don't see how you're stacking blanks, but maybe I'm misunderstanding the question.
Yeah, so we're with the current system kind of a limit here. So it's already one laser head cutting straight, and then the parts being picked up by a double feeder, always two at a time. So it's
Okay.
already pretty much the best you can do. But of course, if you're running bigger parts, the feeder can only take one piece at a time, and then you would be limited with a maximum output of 22 parts with a double feeder.
I would just
Okay.
I would just add that there are different machine vintages that Schuler offers to really build a machine that meets your unique needs. The most recent advantage, which Justine was discussing today, is not the same type of machine we bought. So we have options using robots to adjust blank dimensions. We have options to go into the stacker. The stacking carts are huge. They're 4 meters long. So we can put two small door outer blanks, for example, one pointed east and one pointed west on the same stacking cart. That significantly improves productivity for us. That's what you're going to get with Schuler is a really good engineering group that designs a machine and gives you the features you need to do what you need to do. And then your operators, as they learn, they will generate ideas you never thought of as an executive engineer, for example. That really speeds up productivity. It's got a place in the future. We sincerely believe that.
Very good. Okay, Justine, I think you mentioned 4 kilowatt. Is that the standard machine? Can we add can you add more power to further increase output, or yeah?
Yes. So actually we can integrate lasers up to 10 kilowatt. Yeah, but so we are always looking at the parts if it makes sense or not. So especially thin material is pretty much on speed already with a 4 kilowatt laser. When you're looking at the product mix with thicker material, let's say starting at 3, going towards 6, then it definitely makes sense to increase the laser power to also increase the output.
Okay.
Maybe some words for the lasers. So we are using IPG lasers, but we are also open to add different manufacturers like Trump, for example, in our application.
Yeah.
And these modern fiber lasers being generated are highly reliable. The mean time between failure for these lasers is several 100,000 hours, and IPG provides a beam combining technology. So really, your laser is generated in 500-watt increments and beam combined to generate the full 4,000 or 10,000 watt laser capability. So if you were to have a failure of a laser generator in the house that generates the lasers, you could still operate at a lesser power factor. It might be a little slower while you repair the one module, but we've been operating for 2.5 years and haven't had any problems with laser generation to date. None. And it's IPG.
And you've got a 4K system, Chris.
We have 3 4,000 watt lasers. Yes.
Yeah. Okay. Okay. Thank you for that. Is there an opportunity? So how can people see the equipment live in operation?
If they're willing to email me, we can set up a visit to see the line in operation.
Oh,
We're running 5 days a week presently, but I don't know if anybody wants a tour on a Saturday or Sunday. But we're happy to entertain visitors, and hopefully that will lead to some positive interaction in the future.
Of course.
Terrific.
And even so, depending on where you are connecting right now, so we have lines pretty much installed all over the world. So we can definitely set up a reference visit for you somewhere.
Very nice. Thank you. Talk a little bit about job changeovers, Justine and Chris. How long does it take typically to change the line over?
Well, when you are really stressing the productivity limits of the machine, the volume requirements, you can be loading the second coil while the first coil is tailing out. So that really is an insignificant time frame. You're already threaded through the peeler rolls, through the delivery rolls, and into the leveler before the first coil is tailed out. Then it's just a matter of changing the CAD file programming, just flipping a couple of switches on your computer screen, and away you go. So it could be as short as 4 or 5 minutes, but we're probably averaging now around 15 minutes because we're doing some extra checking. When we change materials, we do have to go through a line cleaning process. So we do run both steel and aluminum. We will change the leveler cassette, as Justine mentioned, that there's options for multiple leveler cassettes to support different materials. So that takes a little more time, but just a coil change, 5 to 10 minutes, a job change, 15 to 20 max. And we're gonna be getting that down to a much smaller number as we gain the experience, and we're pressed to do that. Right now, we're still making a lot of double checks.
Sure.
And so actually what we are having is an offline programming tool. It's called LBS Studio. And here you can design your programs offline. That means the line is producing and you're receiving a new part you would like to process. And then you're setting it up on your computer, making all the trial runs virtually, checking what output to expect, or if you need to adapt your cutting strategy in some way. And then you can directly download this program and upload it to the line. And then the line would go into the settings like defined in that program generated by our software.
That was a point I failed to mention, but yeah, the line does remember all the set points if operators instructed to record them. So the next time you run that same job, it automatically sets everything up in an integrated fashion to the same set points you left it at the last run, which is a very big time saver.
Yeah.
Great. Okay. Now we got a couple minutes if anybody wants to go into that Q&A panel and ask a final question. Chris, I'm curious though, I know we talk about the flexibility that laser brings versus conventional blanking.
Mm-hmm.
Can you speak to, you have examples where maybe you've gone to the customer and been able to use the laser's flexibility to custom develop blanks and save material and maybe help stamping downstream?
Yep. The first and foremost thing that we've demonstrated, even all the way through simulated stamping, is the conformance of the leading and trailing edge of the blank to be the same line. That does two things. One, it allows the two blanks to be nested closer together, but as opposed to mechanical blanking, which requires some stripper land in order to make the mechanical cut, we will cut those with what we call a common line. So yield is further improved by not having, 25 or 40 millimeters of space between the blanks. That is an instantaneous yield savings. We're working with some customers to take a look at making slits instead of holes for expansion and movement of metal from the inside out, which is a technique in the trade. I know that tool and die makers have a whole roster of blank shape improvement ideas that could not be implemented because of the cost of adjusting a mechanical blank die for a trial. These techniques, these ideas can be supported with a new CAD file, put into the laser blanking machine, 25 blanks produced overnight, and they can run their trial and make their improvements. And these guys are really, really excited about that opportunity. And that's one of the initiatives we have going on with some of our customers in a big way right now, is trying to take all those material utilization ideas and implement them in trials and incrementally approach the absolute best in class blank shape possible for that stamping.
And I think you also do a lot of emergency production for customers, so you're also flexible in adding jobs in between.
Thanks for reminding me. We have been called upon for, last coil on earth situations, I call it, where there's a blanker goes down or some facility malfunction in a mechanical blanking plant, and we've been able to turn those around given the CAD file in less than 24 hours in some cases. So from coil receipt to shipping of the emergency quantity, 24 hours to 48 hours, 70% of these we've satisfied in that time window. It's just a whole different world than moving dies, unpackaging dies, setting dies up, testing dies. When you take an emergency source like that, you got a lot of checking to do in your machine. Not to mention that you run into bed sizes which have some limitations. So some dies are too big for presses, or if it's a high strength application, there's not enough press tonnage to make all the cuts. Neither of those is a problem with laser blanking.
Yeah, sure. Very good. Okay, one last question, then we do got to wrap things up. How many of these lines, the LBL 118, are in operation right now, Justine?
So we just launched the new technology. So we have one reference line that is currently installed in our facility, ready to be shipped beginning of next year. So this would be our first reference. We also have a second one laser head system, but this has this stop to cut version I mentioned before with the thicker materials.
Okay, good. All right, well, thank you. That does wrap things up then for the session today. Thank you so much, Justine and Chris, for a really excellent, informative, and detailed presentation. And to our audience, thank you for attending the program and for asking such great questions. We hope everyone found it to be valuable. Once again, an archive of the program will be available on our website within the next day or two. When it's ready, you'll receive an email from us. Then you'll be able to review what you learned today and share it with others within your organization. So again, thank you for attending. Thanks to Justine and Chris. You can close your browsers now, and I wish everybody a great day.
Thank you very much.